We're working some more here in chapter 4. What we're basically doing is leaving the whole concept of just borrowing money and paying it off after a month and adding a one-time interest to it, or borrowing some money, or putting away some money and you're going to be compounding some interest on it just occasionally kind of throughout the life of it. Okay, so we're leaving that world, and what we're going to do here in the second part of chapter 4 is focus more on the payments. Payments meaning, instead of just setting aside some money and letting it just sit there for a whole, 20 years and not changing anything, just letting it sit there, and the only thing that's really changing is just the amount of interest being added, is with the word with annuity. Whenever you see the word annuity, what I want you guys to think of is the fact of not only is interest changing the balance to that savings account, but also payments. You're going to be adding money to it occasionally throughout the life of it. Okay, so instead of just a lump sum sitting there, you're going to start out and then keep adding and adding and adding and adding on top of all the interest, or taking away, taking away, taking away. All right, and there's two types of annuities. The first type is like a future value annuity, and then a present value annuity. So what's the difference between the two? Well, the future value is like what I say here. It's when you're saving money. And in the case, since you're saving money, what you want to consider is like the present value as being $0, because you're starting to save. You're starting at nothing and then you're building up. So eventually what you're going to be doing is building up to a future value of so much money, and that's what we're going to eventually find. Okay, so future value is when you start at 0 and you're building up. So you're making payments to yourself. You're going to be making payments, let's say, for a retirement account. You want to have so much money available after 20 years. If you were trying to save for a college fund, you just had a child and you want to know that when they graduate high school that they have $20,000 or whatever at least to take to college with them, or eventually there's a trip you want to save for. Okay, that's all future value. You're saving for something in the future. What a present value is all about is that you just took on, let's say, a loan today and you want to eventually pay it off. So the key with this is the future value is going to be 0. So the present value is this large amount of money, and your goal is to take it to a future value of $0. That's the goal there. Okay, and the key with present values is really what you're looking at are things like mortgage, or let's say car payments, because that you took the loan out today, you bought the house today, you bought the car today, its present value, the present value of the loan, and your goal is to take it eventually down to 0. Okay, and the best part here about chapter 4 is more of how we're going to be able to use our calculator. Those two formulas that were above, they're great, but I'm not going to ask you to memorize them. You either use those formulas or you use this thing called TVM Solver that's in your calculator. So we're going to use TVM Solver. But what I wanted to show you, let me go back up for that just for a second, is whether you're using that formula, or you're using TVM Solver, they're finding the exact same thing. This is what you're going to see is TVM Solver is so much easier, and there's 2 less formulas to have to memorize. So let's talk about TVM Solver. How you're going to get to it in your calculator is written right over here in this key. It's first of all, you're going to go to your apps button. The apps button is the only one that's highlighted purple. It's found on the second column from the left on your calculator, about 3rd button down. It's in purple, and when that comes up, there's going to be a number list, and the first thing in the list says finance, so just hit enter. It's already highlighted for you. And then the first thing that next comes up says TVM Solver, and hit enter. So it's really easy to get to. You literally hit the apps key, then hit enter and enter, and that's it. And then what comes up is what's written over here in this table on the left. So let me just talk. Obviously you can read through some of these, but let me talk about some key differences here than what we're used to seeing from specifically section 4.1. Let's go to the interest first of all. The key with interest is whatever they give you, if it says 7.2% interest, you just literally type in 7.2. You do not have to convert that to a decimal. It's just going to be 7.2 as is. So not 0.072, just 7.2. So that's one key difference. Another difference is this P/Y and C/Y. No matter what, those two numbers are always going to be the same. And what they refer to is the number of payments in each year, or the number of compounds in each year. And every problem we do, they're going to be the same. Okay? So if you're making monthly payments, like a typical mortgage or a typical car payment, then it's going to be 12 and then 12. Okay? If you are making, let's say you're saving and you're going to save quarterly, then that'll be 4 and 4. But those two numbers are always going to be the same. And the other thing to watch out for is this very first thing, the capital N. The capital N is the total number of payments for the entire life. So if y'all want to write that down maybe, is it what it represents is the whole entire life of the whole entire loan or how long you're saving your money. So even though, let's say you're compounding monthly, you don't want to write 12 right there because 12 is being taken care of down here in the P/Y and C/Y. What that means is it's 12 payments for, let's say, 52 years or something like that. So you're going to be multiplying all that together. It has to be over the entire life or the total number of payments. Let's try here example 1. And you can kind of see what a lot of these mean. Okay, here in example 1, what you're trying to do is find the amount of money in an annuity if $1,800 payments are going to be made each quarter for 6 years, 9% compounded quarterly. Okay, so let's go piece by piece and fill out what we know. We want to find the amount of money in an annuity if $1,800 payments. So I know my payment real quick is going to be $1,800. They're going to be made each quarter, okay, for 6 years at 9% per year compounded quarterly. Okay, so the interest is just 9. Again, we don't have to worry about the 0.09, just 9. We're going to be compounding quarterly, so that's 4 times a year, and it also tells you you're making payments every quarter, so you're making 4 payments. Now let's go to the N, the capital N. Well, this is where the years are going to come in. We don't want to write just 6, because that just means that you're only making 6 payments over the whole life. Well, we're not. We're making 6 payments, or we're making for 6 years, we're making 4 payments every year for 6 years. So a grand total of 24 payments. And the cool thing about your calculator is literally when you get to that step right there, if you want to just type in 6 times 4 and then hit enter, your calculator is going to do all that math for you. It's really, really, really nice. Okay. All right, so next, present value, the PV. Well, because obviously you're trying to find the amount of money that's going to be in the annuity in the future. So the present value we're starting out is 0. So go to your calculator, hit the apps, hit enter, enter, and then what comes up is when you go to the capital N, if you want to type in 24, that's great. Or if you just want to type 6 times 4, then hit enter. Type in 9, hit enter. 1,800, enter. 0, enter. You can skip past the future value for just a second, and then type in the 4 and 4 for both the payments per year and the number of compounds per year. Okay, so now how to find the future value. What I want you to do is go up there and make sure your cursor is just kind of sitting there blinking. And then what you're going to do is hit the alpha key. It's the only key that in your whole entire calculator that's highlighted green. It's right below the second button. So hit alpha and then go down and hit enter. Because if you look right behind the word enter, the enter button, what's in green is the word solve, which is what we're trying to do. We're trying to solve for the future value. Okay. And then when I do this, what comes out is an answer. So I'm going to kind of write it just right down here of negative $56,461.33. So what we've just discovered, and obviously round it to the nearest penny, but what we have discovered is that if you make $1,800 payments just 4 times a year for only 6 years, you're going to have $56,000, almost $56,500 by the time 6 years rolls around. That's a lot of money. But the reason why that really added up fast was the fact that your interest rate was 9%. That is a very good interest rate. If you can get that, oh my gosh, you better be utilizing that as much as you possibly can. All right, let's talk about this negative thing though before we go on to the next problem. It's like, how can I be saving a negative amount of money? Do I owe money? Or, what's going on with that? Let me explain something to you. Let's consider today being the first day. We're making our first payment. So our current balance is $0. I'm going to give the bank my first $1,800 right now. Well, when you think about it, since you're giving that money up, you're not going to be able to use it tomorrow. You're giving it to the bank. They're going to basically keep it from you for the next 6 years. So when you come over here to payment, what you could do is just make this a negative $1,800. Think of it as I'm giving this away, so I need to make it negative. So if you go back into your TDM solver, and instead of go to the payment and type in there a negative 1,800, and here's the key. Don't hit minus 1,800. Make sure you hit your negative key. Okay, the one that's right next to the enter button on the last row down there. Okay, so make sure you hit that one, not the minus button, but the negative button. And when you type that in there, then go back to future value and then re-hit alpha solve. And what's going to come out this time is now a positive $56,461.33. So the magnitude of what you're saving is always going to be the same. It's just if you want to have to worry about interpreting your answer or not. If you consider your payments always being negative because you're having to give up that money, then your answer is going to come out correctly how you need it. Otherwise, you can always just interpret it either way. Okay, but the magnitude always is going to be the same. So, all right, let's try this again though, and let's go on to example number 2. Okay, so as we read through this problem, let's just start assigning values. We want to find the amount in an annuity if $200 payments. So our payment's going to be a $200. We're going to make them, so I'm going to make it negative. We're going to make them each month. So the number of payments per year are going to be 12. And this also says it's compounded monthly. It always will be that way. Those two numbers always have to be the same, okay? And we're going to make it 8% per year. So at 8%. And we're going to do it each month for 20 and a quarter years. Okay, so our N is going to be our total payments. So it's going to be 12 months every year. So 12 times every year for a total of 20.25 years. Okay, so that's what I was saying is how we can go in there and just type in like that, 12 times 20.25, and it'll do the math for us. The present value is obviously 0 because we're going to be saving up this $200 payments. Okay, so if we type all that in, go over to your future value. Once you get the cursor there, hit alpha solve, and let's get the answer. And as we are doing this, I want to make 2 points. When you type in negative 200, make sure that you use the negative key and not the minus key, because otherwise it doesn't like it that way. And by the way, when I type in 12 times 20.25, the calculator comes out to be 243, so make sure yours is showing that too. But okay, so when I go to future value and I ask it to solve, what comes out then is $120,779.92. Okay, so there's our answer. If I just make, if I make just $200 payments every month for 20 years, then $120,000 is going to come out. Can you imagine your parents? If there are, maybe you guys, when you eventually become parents, if you save $200 a month just for a college education for your kids, they're going to have basically $121,000 by the time they're 20. Not too bad. Kind of motivates you to save a little bit when you realize all that. Okay, or honestly, hold on, let me come back to this just for a second. What this is also showing you kind of in reverse, if you wanted to go the other way around, it would take you 20 years to pay off a loan of $121,000. 20 years to pay it off if you only made $200 payments every month. Okay, that side of things not so fun, but yeah, it's something to think about. All right, let's look at example 3. Okay, so in this example, we want to find the present value. So this time we're finding PV, where $1,200 payments, so we're going to be making $1,200 payments, are made semi-annually, so that means twice a year. Payments per year and compounds per year are both going to be twice. We're going to do it for 6 years at 10%. Okay, so we're going to be making it twice a year for 6 years. So those two together. The present value is what we're looking to solve for. And then in this case, the future value is going to be 0. So it's basically, it's like you're basically paying off something. You're going to make $1,200 payments just twice a year. Okay, so let's go over to the present value. Put your cursor in there and let's see what it solves. Okay, and when I do this, I get a present value of $10,635.90. So let's say if you bought a used car for $10,600, and then what you would do is if you made monthly payments, or not monthly payments, just semi-annual, so just twice a year, it would take you 6 years to pay off that car if you made $1,200 payments just twice a year. Okay, so not too bad.